Hi there, my name is Yong-eun and welcome to Namusori. This is the very first lecture of TypeScript. In this lecture, I'll give you a brief overview of TypeScript. And then, you'll learn about the basic features like type system and type inference. Are you ready? Okay, let's get started. TypeScript is a programming language developed and maintained by Microsoft. It is a strict syntactical superset of JavaScript, providing type safety and predictability in your code. Codes written in TypeScript are converted to JavaScript by TypeScript compiler. These are also called transpile. I will explain these parts again later when we set up the development environment and proceed with the actual program together. In order to understand the type system, understanding the basic type system of JavaScript must first be understood. As you all know, JavaScript is a loosely typed or dynamic type language, meaning you don't have to specify what type of information will be stored in variable in advance. This can be clear if you compare to languages with strong types of constraints such as C and Java. I will explain the type system of JavaScript through the difference in declaring variables. When JavaScript declares a variable, it uses keywords such as let, const, and var to define the scope of the variable. For instance, if you want to use the variable named n in JavaScript, the keywords you can put are let, const, and var. Just specify the scope for this variable. However, this may contain any type of value such as number and string because it does not specify the type. These loosely typed languages ensure program flexibility, but they have difficulty implementing predictable or type safety code because you don't know what type of value this variable contains. On the other hand, languages like C and Java specify the type of value when declaring a variable. So, if this variable is an integer type, it is declared int, and if it is a logical type, it is declared a boolean. This is called strong typed or static typed language. The language that allows you to apply the static type system to JavaScript is the TypeScript. As I told you, static type languages must specify the type in the value when declaring a variable. If not, an error will occur during the compliance check. Applying a type system to JavaScript means that you can specify types in variables, parameters, and functions. This allows more safety and predictable JavaScript programming. Of course, you can maintain the inherent flexibility of JavaScript. Now, let's take a closer look at how this type of system is applied grammatically. First of all, let's look at the data types that JavaScript defines. All data types in JavaScript can be generally put into two types, primitive and objects. If you look at the primitive type, number, string, boolean, undefined, and null were the basic data types based on ES5. The type symbol is then newly introduced in ES6. The void type is also used in JavaScript. It is pretty much the opposite of the any type. You can assign only undefined or null data to variables declared a void type. Let's take a look at some examples. If you look to the right, I declared a variable named myVar with the let keyword. This can hold any kind of value including standard data types. This is possible because JavaScript executes line-by-line translation using interpreter. Therefore, the data type for JavaScript is usually referred to as dynamic type. As I told you previously, TypeScript can apply static type to JavaScript. In the next chapter, we'll see how the TypeScript applies the data type. As TypeScript supports the static typing system, you can specify the type of data in variables, parameters, and the return values of functions. Once a type is specified, only the specified data type can be stored in the variable, parameter, and the return values of function. If not, an error will occur during the compliance check. As you can see, you can specify the type using colon plus type after name of the variable or parameter. For a function, the type of return value is defined at the end of the function's signature. Let us suppose that the variable named year is declared. If you specify the number type for this, then you can only store a number type or value not only on the line the variable is declared, but also on the next lines. The same applies to parameters and functions. Basically, the ways you can specify types in TypeScript are for type annotation, parameter annotation, and result type. There is also a way to specify the type using the interface. You will get a chance to take a closer look at how to define the type using the interface later in this course. Next, let's look at the type inference. Writing types is optional in TypeScript because the types can be inferred. The TypeScript compiler infers the type information when there is no explicit information available. It is called type inference. TypeScript infers the type of variable from the value that is assigned. The type inference takes place when initializing variables, setting parameter default values, and determining function return types. As you can see on the left, I declare a variable named name with the let keyword. And I didn't specify a type, but gave a value Kim for the name. In this case, the type of name becomes string as Kim is a string type. Yes, the type is inferred. So, if you declare a variable and assign a value on the same line, the variable will be specified as the same type of value. This name, which has become a string type variable, can only store string type in the following lines. If you look to the right, I declare the variable and do not assign a value to it. Then this variable automatically becomes any type. Any type means a variable that can hold any type of value. In other words, this variable becomes a data that can hold any data type like JavaScript. There's also a way to specify any type directly. Just put any with colons after the name of the variables. This any type variable will not be subject to type checking at the time of compilation. Alright, we've looked at the type system and type inference very lovely so far. In the next lecture, we will actually create a to-do list application with TypeScript and look at the grammar and concepts of TypeScript step by step. I will see you at the next lecture. Bye bye.